is John with lesson 1 for year 13 physics. This is the first lesson for linear motion, and the first lesson is on impulse. So, momentum has to do with the quantity of motion, and the formula associated with momentum is P equals m times v, and here's what the letters stand for with their units. Now, momentum is a vector, so direction is important. Now, motion can be created or destroyed by a force. It is a force that brings about a change in momentum, and hence change in momentum is also impulse. How do you calculate the change in momentum? If the force is constant, we can use the change in momentum as F times delta t, and also you can use delta p is m times delta v, and if you expand this delta v, which stands for change in speed, you can also write it in these two forms. Now, when the force is changing, it is the area under a force time graph that gives you the change in momentum, and depending on the shape of what's under the graph, you need to use the appropriate formula. So this one is a triangle, and and this one is a trapezium. So if you can't remember the formula for a trapezium, you can also change it to two triangles and a rectangle and add all three. Okay, now since the force is changing, it is possible to calculate the average force, which is F is delta P over T. Now, when calculating change in momentum, this should be done by vector subtraction. And when you do vector subtraction, the rule is you add the opposite and taking directions into account. Now, I've done a few problems on this, and you can most welcome to take a look at those. So these are some questions on impulse. And you can pause. So notice for this one, because things are moving at right angles to each other, I have included arrows, and this now translates to a vector triangle where you add them head to tail, and the result or the change in momentum goes from start to finish, and the double arrow is your change in momentum. And if you need to find the size of the force, you divide the change in momentum by the time taken. In this one, it's calculating the area under the graph, and here we go, and then there's one more here, and that's lesson 1 done for you.